Hi, so we're going to be filling out this cardiovascular system cardiac output worksheet. And real quick, I want to show you, first of all, where I am getting this worksheet and where you can access it. And that is on our Blackboard page. So you go to PowerPoints, and if you go to Unit 3 and you go to Handouts, you're going to see physio worksheet, cardiac output. And so this right here is what we are currently going to be filling out. So if you want to stop the video, you can grab this worksheet and then restart the video when you're ready. So I'm going to be writing it on my iPad and filling it out. And once you have your worksheet, we can start this together. So the most important thing is understanding again what cardiac output really is. And cardiac output is how much blood your heart pumps in a minute. So it is a volume per minute, right? And so it's expressed in milliliters per minute or liters per minute. So it's a volume of blood pumped by your heart per minute. And everyone has the same cardiac output needs to some extent. And the average is about 5 liters per minute. Obviously, bigger people need more volume circulating. They just have more square footage, and so requires more blood. Smaller people have less square footage, requires less blood. But we're going to say 5 liters per minute. That's the same as 5,000 milliliters per minute. Okay, that's your average resting cardiac output. And that is just to maintain metabolic needs. You need to deliver so much oxygen to the cells for cellular respiration so they can produce ATP, just to help your nervous system keep going and your muscles keep contracting, and having things pumped in and out, and active transport, and so forth. So what is the equation for cardiac output? Well, the actual equation for cardiac output is equal to your heart rate times your stroke volume. Heart rate times stroke volume. And so heart rates is generally expressed in beats per minute. A beat, by the way, is equivalent to one. Oops. This keeps happening when I try to touch my iPad. Can't let my hand touch it. Uh-oh, it's not gonna work. Keeps sensing my, oh, I know why. I'm getting up into the realm. 1 heart contraction. So 1 beat is 1 heart contraction, and that's how many in 1 minute. How many in 1 minute? And stroke volume is the volume pumped per 1 heart contraction. Or another way to put it is cardiac cycle, right? Cardiac cycle. So this is a cardiac cycle, 1 heartbeat. So how many cardiac cycles in a minute? And so that's where we get the liters per minute. Okay, end diastolic volume. End diastolic volume, if we're describing it, is the volume of blood available in ventricle at the end of diastolic period or period of filling, period in which ventricle can fill with blood. right? The heart's not contracting. And so uh, the ventricle is allowed to fill with blood. It's equivalent to how much blood you have available to pump out, right? And another word for that is preload. So what are two factors that cause the cardiac output to increase during exercise? Okay, so there's two ways, because when you're exercising, you are actually going from maybe a cardiac output of 5 liters per minute at rest. And when you exercise, your metabolic needs go up, your needs for oxygen go up, and nutrients and carbon dioxide to be taken away. And so that requires more circulation of blood. And so your cardiac output can go up to 30 liters per minute. So that's a huge increase in the amount of volume being circulated. And what that amounts to is your heart has to work harder and faster, right? It has to increase heart rate and increase contractility, right? So it has to increase heart rate and increase contractility. And so in order to do that, two things happen. So one, you increase your heart rate, right? You increase the number of contractions per minute. So remember, if cardiac output equals, let's put it over here. Cardiac output equals heart rate times stroke volume. If you want to increase cardiac output, you have to increase heart rate. And the second thing would be increase stroke volume, right? So increasing stroke volume. And so the second thing we'd be looking at is increasing stroke volume by increasing the contraction force of heart. And that can be done by the sympathetic nervous system. Now, this one right here, the result of subtracting end systolic volume from end diastolic volume is called stroke volume, right? So stroke volume is equal to end diastolic volume minus end systolic volume. And end systolic volume is the volume left in ventricle after contraction. Good writing. The product of heart rate and stroke volume is called cardiac output. As you can see, we're going over this in many different ways. The reason I'm going over this in a bunch of different ways is so you start to really learn this instead of just memorize it for a test. Memorizing things for a test is not very helpful overall, especially if you're interested in going into anything that has to do with human healthcare or even veterinary healthcare, because animals also have cardiac output. It's essential for understanding these. And so when you're trying to help someone, if you understand the physiology, you can understand underlying pathology, things that are going wrong. So what are two mechanisms that the autonomic nervous system can increase heart rate? And so there's two ways that it can increase heart rate. One is increased sympathetic activity. So you're just increasing the amount of sympathetic nerve impulses or stimulation. A fancy way of saying increase the number of action potentials to the SA node. So the SA node is the pacemaker cells of the heart, and so that is going to increase the number of times heart contracts, and that's another way of saying increase heart rate, right? The other way is you could decrease parasympathetic activity. So parasympathetic activity, parasympathetic parasympathetic nervous system also innervates the SA node. And if you decrease parasympathetic stimulation of the SA node, then the result is the SA node can actually increase the number of action potentials, because this is rest and digest. And so it's usually slowing down your heart rate, your parasympathetic, and keeping it at a lower rate. And so if you decrease the amount of action potentials from the parasympathetic nervous system, it will increase firing of the SA node and increase the number of action potentials to SA nodes. That will also increase heart rate. So that's two ways. And so while you're exercising or running, you have two mechanisms. Your body has two mechanisms by which it can increase stroke volume. So it has two ways to increase heart rate. It has two ways to increase stroke volume. And one of those is increasing the amount of blood returning to heart. And increasing the amount of blood returning to the heart. Blood returning to the heart is called venous return. Venous return leads to what we call preload, which is equivalent to the end diastolic volume. So what you're essentially doing is increasing the end diastolic volume. You're increasing the amount of blood that you have available. And so that will increase stroke volume, right? Because you just have more volume to pump. So that's one way. And the second way is going to be increasing the strength of the contraction. So the sympathetic nervous system also innervates the myocardium. And so that's the heart muscle. And so by increasing the strength of the contraction, it can actually increase number of cross bridges in the cardiac sarcomeres, and that will increase the force of heart contraction. So if you increase the force of the heart contraction and you have more blood to contract, both of these things are going to result together in an increase in stroke volume. And these things are an increase in heart rate. And so if you increase stroke volume and heart rate, it's going to lead to an increase in cardiac output, because you are multiplying heart rate times stroke volume. It's just going to go up. The last two in this section, how does sympathetic stimulation decrease cardiac output? It decreases cardiac output by decreasing parasympathetic control over the SA node, and that's going to lead to the SA node increasing number of action potentials fired, which is going to increase heart rate. And if you increase heart rate, it's going to increase cardiac output, right? Because it's a multiplication. If you're increasing one, it's going to increase the product, which is heart rate times stroke volume. How could a slower heart rate increase stroke volume? Well, if you lower your heart rate, that's going to lead to more time between contractions. And more time between contractions leads to more time for ventricles to fill with blood. And if you have more time to fill with blood, you're going to end up with a higher end diastolic volume or preload. And so slower heart rates are better for having a higher end diastolic volume, and you're going to lead to more volume of blood available. And if you're a regular exerciser, a cardiovascular exerciser, you're going to have a slower and stronger heart rate, or I should say a slower heart rate, right? So you're fit, you have a slower heart rate, and you have a higher stroke volume. And that means your heart has to even beat less time, so you get a really low heart rate. And it doesn't have to work that hard to maintain cardiac output, and we see this in athletes all the time. So this is going to conclude this segment. We'll have the cardiac cycle in our next segment.